Okay, students, welcome. So this is a quick tutorial on how to deal with a concept in chemistry called percent composition, which relates to another concept called formula mass. So what I did was try to create an analogy here. So here's an analogy that I've come up with. So let's say that we invented a new candy item that we're going to market. And that candy item, we're going to call it Skirdittle, because really all a Skirdittle is it's 4 Skittles attached with 5 nerds, and they're kind of glued together or bonded, kind of like chemical compounds are. So what we sort of notice is that there's a ratio of 1, 2, 3, 4 Skittles, but 5 nerds. Notice we left out the nasty green Skittles, that green apple. So anyway, so here we go. What we do know is we know that actually, if we were to factor in the percentage of candy item, that Skirdittle would be 78.3% Skittle and 21.7% nerd. Now that seems kind of odd. There's actually more nerds. There's 1, 2, 3, 4, 5 nerds in the Skirdittle. But it's only 21.7% nerd. And you can see that nerds are pretty tiny in size compared to Skirdittle. So actually, if you take a bite, you're getting quite a bit more Skittle than you would nerd in terms of mass. How heavy it is, most of that candy is made of Skittle candy, not nerd candy. And that kind of is the analogy that we're going to take a look at. So let's say our formula for our Skirdittle is S4, 4 Skittle, and 5 nerd. And let's say that we knew that the average mass of a Skittle was 0.45 grams, and for a nerd, it's 0.10 grams. So we weighed them and we got kind of like an average for them. So what we would do is we would break down the candy into the types that make it up: S, Skittle, N, nerd. We'd look at the counts, the quantities in one Skirdittle. There would be 4 Skittle, 5 nerd. Then we would look at or factor in the mass of each. Well, an average Skittle, 0.45 gram, and average nerd, 0.10 gram. Next, we would get the contribution, the total contribution from each candy item. That would just become by multiplying our count, our number, by our mass. And that would give us 2 quantities, 0.5 for nerd and 1.80 for Skittle. And then really what we would do is we would add that together, and that becomes the whole quantity. The whole quantity is 2.30, let's say it's grams. Out of that 2.30 grams, only 1.80 comes from Skittle, only 0.5 comes from nerd. So we compare the parts to the whole. Now the whole is actually called formula mass, but really we're comparing the part from Skittle, 1.80, to the whole, 2.30, and that whole we call the formula mass. It's kind of like the mass of the entire formula. So compare the parts to the whole by division. 1.8 out of 2.30, meaning 1.8 divided by 2.30 times 100, 78.3% Skittle. The part nerd, 0.5 out of 2.30 times 100, 21.7% nerd. So this strategy is the identical strategy that we're going to use for chemical substances. Now let's apply it here for chemical substances. Let's pause this for just a moment. Okay, so let's take a look at a couple of examples that are actual chemical compounds. So here we got a chemical compound, and it's called copper 2 nitrate. And it says we want to determine the percent composition for copper 2 nitrate. Now there is something we want to be careful of with this. We want to be careful of what's going on right here with these parentheses. These parentheses indicate that everything inside those parentheses get multiplied by the subscript, the number 2 out here. So it's almost like in math, distributive property. So anytime that there's no number associated with an element, like the N here, there's an assumed 1. So 2 times 1 for N and 2 times 3 for O. Notice the Cu's not in the parentheses, the copper. So the 2 does not apply to the Cu or the copper at all. All right, so let's break down the strategy again. So what we want to do is we want to get the formula mass for the entire compound first, the whole amount of mass. Okay, so here we go. We look at the types of elements. We got copper, we got nitrogen, we got oxygen. Next thing we do is we look at the number or the count that comes from the formula. Since there's no number that follows copper, there is a single copper atom. We assume it to be A1. 2 nitrogen, because there is an assumed 1 inside the parentheses for N, but a multiplier of 2 out there. There are 2 of these ions that we call nitrate, and nitrate's made of both nitrogen and oxygen. So 2 nitrogen, 6 oxygen, 2 times the 3 that's in the parentheses for the up. Next thing we do is we look at the periodic table for the mass of each element. So let's take a peek at that for just a moment. So we'll go to our periodic table and we'll take a peek at the atomic mass for those elements. And those elements that we have, here's where we're getting the data from. Copper, 63.55, nitrogen, 14.01, and oxygen, 16. So that atomic mass data comes from our periodic table. Now let's go back to our example. Okay, so our types, our quantities, our mass, right? Those come from the periodic table, those masses, the atomic mass of each element. The contribution that comes from each element, that comes from multiplying, right? We multiply our quantity times our mass, and we're going to get a contribution from each of the 3 elements when we do that. So we get a contribution of copper, nitrogen, and oxygen by multiplying the number by the mass. Finally, what we do is we add up those contributions from the 3 individual elements, and we get what a whole quantity of 187.57 grams, which is called the formula mass, or it is the whole quantity of the entire formula. So I like to call it the whole. You'll compare the parts to the whole. Again, the whole is called the formula mass by division. So the part from copper, 63.55, compared to the whole called the formula mass, 187.57, multiplied by 100. So divide, multiply by 100, and you'll get 35.48%. Likewise, we do the same thing for nitrogen. The part for nitrogen, 28.02 out of 187. So divide 28.02 by 187.57 times 100, 14.94% nitrogen. Likewise, we do the same for oxygen. The part is 96 out of the whole of 187.57. So notice oxygen is the highest percentage because oxygen contributes the greatest mass to the whole. Oxygen contributes 96 out of the 187.57 grams. So let's take a quickie look at an example that does not have parentheses in it. Far more straightforward. 2 NAs, 1 O. So our types, sodium and oxygen, Na, right? The counts, 2 NAs, 1 O. The atomic mass comes from the periodic table, 22.99 if it's sodium, 16 if it's oxygen. The contribution, multiply number times mass, add up those contributions to get the whole amount that we call the formula mass. Compare the parts. The part from sodium, 45.98 out of 61.98, that means division, times 100. We get 74.19% sodium. We do the same thing for oxygen, 16 out of 61.98 means division, times 100, 25.81% oxygen. So this is a nice set of examples for how we calculate percent composition data, knowing that it's based on something called the formula mass, which is kind of like the entire mass of the formula for the chemical of interest. Until the next time, this is Mr. Brewer, and I'll see you guys real soon.